Hello, welcome everyone. So this is the question number 8 of rotate bits in bit magic of Geek for Geeks must do coding questions for interview. Just have a quick look at the question on the screen, or you can visit the website of Geek for Geeks and check the question there. Now let's go to the approach. Before that, please don't forget to subscribe and like the video. If you have any doubt, just leave a comment below. Now let's go to the approach. In this question, what is the approach? Before that, we have to understood what is the meaning of the question first. So let's understand it. Here in this question, what he is saying, there is a certain number given. In this case, which is 28. If you convert that 28 to the binary, we got this value here below. This is the binary value, and this length should be equal to the 16. Okay. If we count, this will be equal to the 16 bits. The total length will be 16. And remember, whatever number the data can be, in this case we got 28, but if you get any other number other than 28, everything should be represented in 16-bit form. Okay, for that we have to check, after converting it to the binary, we have to check if it is equal to 16 or if it is less than 16. If it is less than 16, we have to add the zeros on the left side. Now, how will we do that? In this example, you can clearly see up to this 5 bits only, the binary value is correct. And this will be equal to 28 without zeros. But the question says we have to include 16 bits for sure. Now, what we can do is we got the length of 5 here, which is equal to 28 here. 11100 is equal to 28. So the length of that is 5 here. Now, but we need 16 total values. So what we have to do is just subtract 16 and minus 5. 16 minus 5, we get 11 here. So what we are doing is, after converting it to the binary number, now we have to use concatenation here. Okay, by concatenation, I mean we got 1 1 1 0 and 0, right? This is the value of 28. Now how will we use concatenation is, by, you can see clearly in this example, we're adding zeros on the left side. Okay, on the left side we have to do it similarly. 60 minus 5, we got 11, right? So what we are adding? We are adding zeros here, and take the string format of 0 and multiply with 11 here, which is a difference of 16 minus 5, 11. Okay, if we do concatenation, we get the value below which was given below. Okay, this is in case of 28. Now there is one more problem here. Now let's check what is the problem here. Okay, that one more problem here is, here it has given 2 bits, which are the rotation of bits. Rotation of bits is nothing here. We just have to shift the number of bits. Whatever the d value is, we have to shift the same number of bits, okay, to the left and the right side. If you look into the example carefully, 28 is the number which was given to us. Now we're shifting 2 bits, okay. For rotating left by 2 positions means we're taking 2 bits from the left side and we are adding it to the right side here. Okay, those 2 bits here which was given, this is the left rotation here. In this left rotation, just simply shift this left position to the right one. Okay, that will make the left rotation successful. It is 2 bits, that's why we're taking 2 values. If it is any value 4, 5, 6, 15, 14, then we shift the number of bits to the right side. So here you can count, you can see there is a difference of 0 0 in this 0 0, and there is no extra zeros here above. So we shifted left side 2 bits of 0 to the right side. Similarly, rotation right means we're taking the 2 bit values on the right side. Okay, the right side is this one, this is the right one. Okay, this is R, this is the right side bits. In this case, D is 2, that's why we are taking 2 bits from the right side and we are concatenating to the left side. Okay, we can use slicing here. After using concatenation, we get this value, and this is fine. The problem is, what if d value is greater than 16? Then what will you do? Yeah, 16 is fine. Okay, now he has given 16. Now if he says again as equal to 16, we have to shift all 16 to the right side. But if the value exceeds the 16 bits, then what we do? Then we make that value into the under 16 number. Okay, we can use modulus here. Okay, suppose d is equal to 18 here. Okay, now d is equal to 18. So d equal to 18, but number of bits is 16. How can we shift a 18 if their number of bits are given is 16? So use modulus. If you use modulus here and 16, you get value 2. This is the same number which was given. So we just update the value by using modulus. If the number exceeds, if d exceeds 16, then only we use this. If we the 6 if d doesn't exceed 16, we don't use the modulus here. Okay, by doing this, we're giving a clarity to ourselves at what bits we have to shift. The 2 bits means we are shifting the left side 2 bits to the right, and similarly right side 2 bits to the left side. But if you use 18 directly, how will you imagine in your mind how you will be shifting the bits? Okay, you cannot imagine that simply. So if you use a modulus operator here, it will give you the number which is below 16. You can easily imagine shifting 2 bits from the right side and the left side similarly. Okay, so I will give you a brief important key points here. First is this one, modulus operator one. Keep in mind, if d value exceeds 16, we have to convert it below 16. Okay, and one more is we have to use concatenation to make the value of the to make the length of the value equal to 16. Okay, this is the second important point, and this is number one important point. Without this, you will get so many errors. You have to convert under 16 d value. Okay, these are the two important points that I have mentioned. I hope you have understood what I am trying to convey. If you haven't understood, then just leave a comment below what is the problem. I will quickly respond to the comment. Now, if you still haven't understood the basic approach, then let's move on to the coding session. And I hope after seeing the coding problem, all doubts will be cleared. Now let's move to the coding session. Where inside the Geek for Geeks website, I have already solved the problem here. And have a look here, quick look here. See, here and I have converted the number to the binary format. After converting it to the binary format, convert it into the string here. Okay. In this case, you can assume this 28 example only from the left side. This will convert the binary number to 11100. Of course, only this part will be there inside the binary string here. And we are using slicing operator from second index because first two values will be 0b, and I have mentioned so many times in this video that binary operator adds 0b extra values to the left part of the binary value. So we are excluding them by using the slice operator. So we will be remained with only this binary number 11001. Okay. So after that, if you can see the length of n is smaller than 16, yes, length of n is smaller than 16 here. It has only 5 bits. Now we have to add those remaining values. 16 minus length of n, which is smaller than 16, we add number of zeros to the left side and concatenate, and we get the new value n here, which will be this total value. Okay, after concatenation we get this total value on the left. After that, we are adding one more condition. What if d value is greater than 16? In this case, how will you know the interpreter that we have to move the value greater than 18? You cannot imagine that very simply. So we're using modulus operator to convert it to a smaller number which is below 16. Okay, basically it is a repetition, like I have mentioned previously. If d is equal to 18, okay, just count till total value 16. Okay, now we are shifting left position. Let's count. Okay, now we got 16 value till this part. Okay, this is 16 value. Now just repeat it from the left side. The values are all over after counting till 16. 17 and 18 are remaining. Now we again come from left side. This is the 17 and 18. Okay, so 17 and 18, how many values are there? 2 values. By doing the modulus, we get the same value, which is 2 here. Okay, so that is the usefulness of modulus. It will convert whatever the number is greater than 16 in D to a smaller number, which is smaller than 6. So that number is very useful going forward here. Here we got the number, index number here we got, okay, and we got the index number here. So by using index number, I just keep the index number here, okay, the left side. Okay, I include everything. Okay, for example, here index number is 2 in this example. Okay, what is happening in left is it is taking all the values from the right side, from index 2 to all the values from the right side. Okay, this is the value of that, and this one is the value from the left side of 2 index. Okay, left side is this value. These two values we are adding it to the right side. Now that means it is a left shift, and that will be updated in the left variable. Similarly, in the right, we're doing the minus of that index. Okay, if we do the minus of the index from the total length, it will give us the index from the left side of the array. From the left side, if we count, we get the value. 16 minus 2 is 14 here. Okay, 14, which is index number, and this is the 14. Okay, this is 0 1, I guess 13 14. 14 is the length here. This should be 13. Okay, this should be 13 in index, but value total length will be 14. Index is 13 here. 14 is this one. These two values. Okay, we got 14 here, which is the starting of the index. 16 minus 2 is 14. So 14 to all the number from the right side. So these are the values that we have to shift to the left side. So that's why we are mentioning that in the left part of the concatenation, 0, 0 will be added to the left side, and the remaining values will be added to the right side. This will become our right shift here. Now we have to convert it to a decimal number. For that we use int operator here. Just use int and brackets the value which we have concatenated, the variable name, and the base number. Okay, base number here is 2 for the binary, so we're using 2. If you want to convert from octal, just change the base number to 8. It will convert from octal to decimal. Okay, now this int operator has converted to a decimal format. And now finally we are returning the left and right shift. And this will be our final answer for this question. I hope you have got the clarity what is happening in this question. If you like the video, please give us a like, and don't forget to subscribe. If you have any multiple accounts, just subscribe with all those accounts, and that will be very helpful for our channel to grow in the future, and we will bring more interesting videos like this. Thank you for watching till then. Let's meet in the next lecture.